Hi, and welcome to Lecture 9, Momentum. In this lecture, we're going to talk about what momentum is, the law of conservation of momentum, and then we're going to practice some problems that involve collisions in one dimension and also collisions in two dimensions. All right, so what is momentum? The symbol for momentum looks like a letter P over here. And notice there's a vector over it, which tells us that it is a vector quantity. It has both a magnitude and a direction. It's a property that every moving object has due to its mass and its motion. To calculate momentum, there's a simple formula that will be provided to you on any formula sheet during your test and exam. And the formula is momentum is equal to the mass times the velocity. Notice that velocity is a vector, and so is momentum. Whatever direction the velocity vector takes, so does the momentum vector. Okay, so they're both going in the same direction. All right, so conservation of momentum. So when two or more objects collide with one another, the total momentum of the objects before the collision has to equal the total momentum of the objects after the collision. That means that momentum is always conserved. So as an equation, we can use this formula here, m1v1, which is the momentum of one object initially before the collision, plus m2v2, which is the momentum of a second object initially before the collision, and you can repeat that for all the objects that you have, is equal to m1v1, so the momentum of the first object again after the collision, so F final stands for after the collision, plus m2v2, which would be the momentum after the collision of the second object, and you can repeat that for all the objects that you have involved in that collision. Okay, so we're going to use conservation of momentum to solve all of these problems today. All right, so let's start with the first problem. It says a 2 kilogram ball has an initial velocity of 3 meters per second to the right and collides with a 3 kilogram ball, which has an initial velocity of 1 meter per second to the left. If the final velocity of the 2 kilogram ball is 2 meters per second to the left, then what is the final velocity of the 3 kilogram ball? All right, so we have two objects, they collide with each other. We know from conservation of momentum that their total momentum has to be conserved. So that means the total momentum before the collision is equal to the total momentum after the collision. So we'll start off by writing that. I'm going to say P total, the total momentum of all the objects before the collision, so that's initially, is equal to the total momentum after the collision, final. So how many objects do we have? We have a 2 kilogram ball and we have a 3 kilogram ball. So we have two different objects. So I'm going to write out the formula as we see above, that's highlighted there for you. So the mass of the object 1 times the velocity of object 1 initially, so before the collision, plus the mass of object 2 times the velocity of object 2 initially before the collision is equal to the mass of object 1, velocity of object 1 after the collision, plus mass of object 2, velocity of object 2 after the collision. All right, so on the side, let's write down what do we know about these objects. So I have a 2 kilogram ball and a 3 kilogram ball. So I'm going to say mass 1 is the mass of the 2 kilogram ball, which is 2 kilograms. And mass 2 is the mass of the second ball, which is 3 kilograms. All right, so now we have the initial velocities of each of them. So we know the initial velocity of mass 1 or ball 1 is 3 meters per second to the right. So we need to decide which way is going to be the positive direction. Let's say positive is to the right, then that would mean V1, the velocity of object 1, ball 1, the 2 kilogram ball, is 3 meters per second. And it's positive because we said right is positive. It collides with a 3 kilogram ball, which has an initial velocity of 1 meter per second to the left. So V2, initial, V1 initial was 3 meters per second. V2 initial is the initial velocity of ball 2, which is 1 meter per second. But since it's going to the left, and we said plus is to the right, we would make that a -1. That's very important that we remember to put in the negative sign there. The final velocity of the 2 kilogram ball is 2 meters per second to the left. So the 2 kilogram ball is the first ball, so that's V1 final, because it's the final velocity, it's the velocity after the collision, and it's 2 meters per second, and it's going to the left, so that makes it negative. All right, so there we have all of the values that we know, and we're simply just going to plug in everything that we know into this formula. The question's asking, what is the final velocity of the 3 kilogram ball? So which variable is that? The 3 kilogram ball was ball 2, so that's m2. And we want to know the final velocity. So that's this variable here, v2 final. That's what it is that we're trying to solve for. So if we like, before subbing in any values, we can isolate for that v2 final. Okay, so I'm going to do that right now. I'm going to take the m1 v1 final and move it to the left side of the equation first. So I have m1 v1 initial plus m2 v2 initial minus m1 v1 final equals m2 v2 final. Okay, I just want to isolate for that v2 final, so I'm going to divide both sides by m2. And then I'm going to rewrite the equation with v2 final on the left side instead. So I have v2 final is equal to m1 v1 initial plus m2 v2 initial minus m1 v1 final over m2. Now I'm ready to just substitute all the values in that I know. v2 final is equal to m1, which is 2 kilograms. v1 initial is 3 meters per second. I can put the units here if that's helpful, so I'll do that here. 2 kilograms. You don't need to put the units in though. As long as everything is in SI units, your final answer will be in SI units as well. So we have 2 kilograms, v1 initial is 3 meters per second, plus m2 is 3 kilograms, v2 initial is -1 meter per second, minus m1, which is 2 kilograms, times v1 final, which is -2 meter per second, all over kilogram. Okay, notice that kilograms is in each of the terms up above, so the kilograms could actually get factored out of the numerator and then canceled out with the kilograms in the denominator. So I'm just going to cancel all these kilograms out with the kilograms that you see in the denominator. And so the units then would be meters per second plus meters per second plus or minus meters per second, so it's still just meters per second. And those are the correct units for velocity. So if I type this into my calculator, I'm going to have v2 final is equal to, and on the bottom I don't think I wrote down m2, so m2 was 3 kilograms. So let me write that in, 3.0 kilograms. Okay, so I'm going to type this all up. So I have 2 times 3 plus 3 times -1 minus 2 times -2, all in the numerator, divided by 3. And my answer is 2.333. So I'm just going to write that, 2.333. The units are meters per second. And the question's asking for velocity, which means I need to give a direction. So in brackets, I'm going to write down what the direction is. Since my answer is positive and I identified that positive is to the right, then that would mean it's going to the right. And that's my final answer. Okay, so let's do this again in question 2. Two ice skaters push off against one another, starting from a stationary position. The 45 kilogram skater acquires a speed of 0.375 meters per second to the right. What velocity does the 60 kilogram skater acquire? All right, let's just draw a little picture of what this looks like. So I have two skaters and they're facing each other. I'll draw them in two different colors. Okay, so initially what's happening is they're both at rest. Okay, then they push off of one another and they end up looking something like this. The first skater is moving to the left and the second skater is moving to the right. Right? So you push off of each other, one person moves to the left, the other person moves to the right. So that's the final state. So let's write out all the information that we know about these two skaters. So we'll start with M1 and M2. So we have two different skaters. Let's say this person here is 1, this person here is 2. So M1, they tell us the first person's mass is 45 kilograms. M2, that's the second person's mass, 60 kilograms. Initially, what is the speed of the two skaters? So V1 initial and V2 initial. Initially, before they push off of each other, they started from a stationary position, meaning they're both at rest. So initially, both of their velocities are 0 meters per second. All right, so what about final? We have V1 final and V2 final. The question says, what velocity does the 60 kilogram skater acquire? So the 60 kilogram skater is the second object, mass 2 is 60 kilogram. So V2 final is what we're looking for. That's our question mark. And it says the 45 kilogram skater, which is the first object, acquires a speed of 0.375 meters per second to the right. All right, well, let's define which way positive is first. So we'll say positive is to the right. So then that means that V1 final would be 0.375 meters per second, positive, since it says that that person's going to the right. So now we have all the information that we need. And we can write out the formula that we used before. So we can say the total momentum initially before the collision is equal to the total momentum final after the collision. And by collision in this case, it's kind of like not really what we think of normally as a collision, but two people pushed off of each other. So it's almost like they collided, but they pushed off each other. We can still say initial and final. Okay, so initially we have two objects, so we have M1 V1 initial plus M2 V2 initial. If we had three objects, we'd keep going and say plus M3 V3 initial, but we only have two people here. And then we'd say is equal to M1 V1 final plus M2 V2 final. Now let's decide what is the variable that we're looking for. It's V2 final. That's this one right here. So let's go ahead and just isolate for it now. Okay, so I'm going to take this M1 V1 final and move it to the other side of the equal sign. So I have M1 V1 initial plus M2 V2 initial minus M1 V1 final plus equals m2 v2 final. Okay, so all I did was I took this term and moved it to the other side of the equal sign, making it negative. Okay, so now I'm going to isolate for v2 final by dividing both sides by m2. So I'm just going to divide this side by m2 so that it cancels out. And then I'll have to divide the other side by m2 as well. So now my formula, I'm going to just flip the two sides. I have v2 final is equal to m1 v1 initial plus m2 v2 initial minus m1 v1 final all over m2. All right, so v2 final then is equal to, let's sub in all the values that we know. m1 is 45 kilograms. v1 initial is 0 meters per second plus m2, which is 60 kilograms, times v2 initial, which is 0 meters per second, minus m1, which is 45 kilograms, times v1 final, which is 0.375 meters per second, divided by m2, which is 60 kilograms. All right, so again, if we're taking a look at the units, you'll see all the kilograms on the top. We'll cancel out with the kilograms in the denominator. And now I can just type everything onto my calculator. v2 final is equal to 45 times 0, so that all cancels away, plus 60 times 0, which also all cancels away, becomes 0, minus 45 times 0.375, and then divided by 60. And we get negative 0.28125 meters per second. All right, so why is it negative? What velocity does the 60 kilogram skater acquire? So when I labeled 1 and 2, I actually didn't do that correctly, so I'm just going to erase that 1 and 2 that's there. I'm erasing their heads and part of their bodies here. So let me fix this. I'll do the same thing for the second person. Okay, so let's decide again which person is object 1 and which one is object 2. So it tells us that v1 final is positive. So v1 final is moving to the right. So object 1 ends up moving to the right. So of these two people, the blue and the green, which one ends up moving to the right? That's the green. So green is object 1, whereas blue is object 2. And then same with beforehand, green is 1, blue is 2. All right, so does it make sense that the final velocity of object 2, the blue person, would be negative? Well, yes, because we know that that blue person pushed off of the green person and is going backwards now, so is moving to the left. So rather than writing a negative, we want to give a direction. So I'm going to write v2 final is equal to 0.281. I won't put in too many decimal places. 281 meters per second. And in brackets, I'll write the direction as left. Okay, so make sure that things make sense to you. One of the most common mistakes when doing these problems is that people forget to put in negative signs when something is going in the negative direction. You should always begin by defining which way is the positive direction. And you could have defined left to be positive and you still would have gotten the same answer. Okay, so that's totally up to you. All right, let's move on to question 3. Inelastic collisions. So sometimes when two objects collide, they will stick to each other and move together. And this type of collision is called an inelastic collision. So let's say you have two pieces of clay and they get thrown at one another and then they move, but they're moving together because they're stuck together. That would be an inelastic collision. The formula that we're going to use is pretty much the same, except after two things that are being stuck together, when they move together, we're going to treat them like they're just one bigger object rather than two small objects. Okay, so let's go ahead with question 3. We have a 1,500 kilogram car, which is driving 100 kilometers an hour north, and it suffers a head-on collision with a 3,000 kilogram truck, which was heading south at 120 kilometers per hour. We want to know what are the initial velocities of both cars in meters per second, and if the two vehicles lock together, what is their final velocity in meters per second, and what is their final velocity in kilometers per hour. Okay, so before we begin, the question's asking us to convert the units to SI units. So initially, what are their two velocities? So let's say the 15 kilogram object here is object 1, and the 3,000 kilogram truck is object 2. Then we would call this V1, the 100 kilometers an hour is V1 initial, and the 120 kilometers an hour is the V2 initial. So this is before the collision. So let's change those V1 initial and V2 initials to be in meters per second instead of kilometers per hour. So part A, V1 initial is 100 kilometers per hour, and we're just going to change it to meters per second. So we're going back to what we learned in lecture 1. We want to get rid of kilometers. Right now, kilometers is in the numerator, so we're going to put kilometers in the denominator, and instead we're going to put meters in the numerator. Now we have to write the equivalence. How many meters are equal to how many kilometers? 1 kilometer is the same as 1,000 meters. Okay, so now we've canceled out our kilometers, but we still have hours, so we need to convert hours into the SI unit for time, which is seconds. Since hours is in the denominator, we're going to put hours in the numerator so that they'll cancel out. And instead of hours, we want seconds. Now we have to write the equivalency. How many hours are equal to how many seconds? 1 hour is the same as 3,600 seconds. And so now we just need to type this up on our calculator. So V1 initial is equal to 100 times 1,000 divided by 3,600. We don't need to worry about the ones because timesing and dividing by 1 doesn't do anything. And we're left with 27.777, and it keeps going on, so I'll put an 8 at the end to round it up. Okay, so that's V1 initial. Let's do the same thing for V2. So V2 initial was 120 kilometers per hour. Notice I'm putting the hours in the denominator. I'm making it very clear. Rather than using a slash, I'm using this horizontal line to show that it's in the denominator. I'm going to change kilometers per hour to meters per second in the same fashion that I did with V1 initial. So kilometers, I want to cancel it out, so I'll put it in the denominator. Instead of kilometers, I want meters. 1,000 meters is the same as 1 kilometer. Moving on to hours, we want hours to cancel out, so we'll put hours in the numerator. Instead of hours, we want seconds, and 1 hour is the same as 3,600 seconds. So our units cancel nicely. Kilometers cancel with kilometers, hours cancels with hours. So V2 initial is equal to, we can type this on our calculator, 120 times 1,000 divided by 3,600. And we get 33.3333. meters per second. Let's put the units in for V1 initial as well, meters per second. All right, and I'll just show how the hours also cancels out for V1 initial. So we're left with meters on top, seconds on the bottom. So that was part A. Now part B. If the two vehicles lock together, what is their final velocity in meters per second? Okay, so let's move along to part B. So again, we have a collision, and for all these collisions that we're doing in this course, momentum is always conserved. So that means that P total initial, the total momentum of all the objects initially, is equal to the total momentum of all the objects final, after the collision. So how many objects do we have before the collision? We have two objects. We have a car and we have a truck. And we're saying the car is object 1 and the truck is object 2. So we have M1 V1 initial plus M2 V2 initial equals. Now how many objects do we have after the collision? Well, the collision was an inelastic collision where the two vehicles locked together. So that's the key there. We know the two vehicles locked together. And if they're locking together, that means they're moving together. And we're just going to treat them like they're one big vehicle or one big object. One object that's made up of two vehicles stuck together. Okay, so we really just have one object at the end. What is the mass of that one object? It's two things stuck together. It's a car and a truck. So the total mass of that object is M1 plus M2. So it's the mass of the car plus the mass of the truck times the velocity, the final velocity of both of the objects, final. Okay, so I can put a little 1 and 2 here. This is the velocity of both of them together. I'll call it V12. So that's the velocity of both the truck and the car that are stuck together. Since they're moving together, they have to have the same velocity. And then final. Okay, so this question is very similar to what we've done previously, except for the fact that we know that the final momentum is only consisting of one object. So it's the mass of the total object because two objects are stuck together, making it really just one, times the velocity. Okay, so on this side, I'm just going to write the formula for momentum is equal to mass times velocity. So that's why our momentum is being replaced by mass times velocity for each object. But in the final condition after the collision, we really only have one object now because the two masses are stuck together. So we're going to solve for what we're looking for. The question asks, what is their final velocity in meters per second? So we're looking for that V12 final. So I'm just going to rearrange the formula. It's being multiplied by M1 plus M2. So I'm just going to divide both sides by M1 plus M2. So that these two cancel out, and I'm left with V12, so the velocity of both the car and the truck, which are stuck together, final, is equal to M1 V1 initial plus M2 V2 initial divided by M1 plus M2. All right. Okay, so we found our values, our velocities, V1 initial, V2 initial in meters per second, but I don't think we took really a good look at which direction things were going. So let's look at that now. So V1 we said was 100 kilometers per hour north. Now we need to decide which way is positive. So we can decide, we can say north is positive. I'm going to say north is positive. Okay, so north is positive. So that means that V1 initial was, which we found was 27.7778 meters per second, is positive. So that's good. But V2 initial was heading south originally. So then that would be a negative because north is positive, so south would be negative. So this value here, we need to remember to put in the negative sign. Okay, so now we know whether the velocities are positive or negative, and we're ready to plug them into the equation that we just found for V12 final. If we forgot to put that negative in, everything will be wrong. So it's really important to always consider which way is the positive direction, and then give things positive or negative signs depending on which direction they're going. Okay, so I have m1. Let's write out what m1 is equal to. M1 is the mass of the car, which is 1,500 kilograms, and M2 is the mass of the truck, which is 3,000 kilograms. And we know V1 initial over here, and we know V2 initial over here. So these are the values we're going to substitute into the equation. All right, so we have M1, which is 1,500 kilograms, times V1 initial, which is 27.7778 meters per second, plus M2, which is 3,000 kilograms, times V2 initial, which is negative 33.3333 meters per second, divided by M1 plus M2. V12 final. Okay, so we're just going to type this into our calculators. So we have 1,500 times 27.7778 plus 3,000 times negative 33.3333 divided by 1,500 plus 3,000, and we have negative 12.96. The kilograms, so on the bottom we have kilograms and kilograms. They cancel out with the kilograms that are in the numerator. So if we factored out kilograms in the numerator, we factored out kilograms in the denominator, then all of the kilograms would just cancel one another out. So they'd all be gone. And so the units that we're left with are just meters per second. All right, so we can see that it's a negative. So what does that imply? V12 final is 12.96 meters per second. And which direction is that going? Since we had a negative value, instead of it going north, it would be going south. So the two cars collide, they lock together, and they move south. Okay? Moving on to part C, the question is now asking us, what is their final velocity in kilometers per hour? So now we just need to convert the 12.96 meters per second south into kilometers per hour. So let's go ahead and do that here. V12 final is equal to 12.96 meters per second. Now we want to change meters per second to kilometers per hour. Let's rewrite the fraction so it's clear that meters is on top and seconds is in the denominator. We want to get rid of meters, so we're going to put meters in the denominator. And instead of meters, we want kilometers, because the question is asking us to change the units to kilometers per hour. Now we write the equivalency. 1 kilometer is the same as 1,000 meters. We also need to change seconds to hours. So we're going to put seconds in the numerator, hours in the denominator. Write the equivalency. 1 hour is the same as 3,600 seconds. And now we can just type this up on our calculator. So I'm just entering 12.96 times 3,600 divided by 1,000. And we get 46.66 kilometers per hour. Notice that meters cancels and seconds cancels. And we're just left here with kilometers on top and hours on the bottom. Kilometers per hour. So that was question 3. So far all of the questions that we've done, in the collisions, they've always been in one dimension. So that means that one object is moving up while the other one moves down, or one object moves left, the other one moves right, or maybe they're both moving in the same direction. They're both moving to the right. Either way, that's all in one direction, one dimension. Okay? But what happens when the two objects collide at an angle? So they're not just hitting each other, like one's going left, the other one's going right, but one maybe is going up while the other one's going right. Okay, so they're hitting at each other at an angle. It's not just a head-on collision. So since momentum is a vector quantity, when you add momentum in two dimensions, the vectors could be decomposed into x and y components, just like we did when we first talked about vectors. We can also add those vectors together by adding the x components of each of the vectors and the y components of each of the vectors and recompose them to find the resultant. Okay, so if you want to at this point, you might want to stop and review the vector addition lecture if you've forgotten how to do this. Okay, so we're going to do question 4. And in question 4, you can see that we have a 1,000 kilogram car that's approaching an intersection traveling north at 20 meters per second, and a 1,200 kilogram car that's approaching the same intersection traveling east at 22 meters per second. The two cars collide at the intersection and lock together. Ignoring any external forces that act on the cars during the collision, what is the velocity of the cars immediately after the collision? So this is similar to the question that we just did. We have two cars that are colliding, but they're stuck together, so it's an inelastic collision, but they're not head-on. One is not going north while the other one's going south. One's going north and the other one is going east. So let's just draw a quick picture of what this looks like. So we have a car. Let's say car is object 1, and it's traveling north. So this is north, east, south, west. It's traveling north. So I'm going to say V1 initial is 20 meters per second. And then we have a 1,200 kilogram car, which is approaching the same intersection traveling east at 22 meters per second. So here's my other object, object 2, and it's traveling east. So V2 initial is 22 meters per second. And the two cars collide. So this is initially. So it's before they've collided. And at the end, what's going to happen? They're going to crash into each other and they're going to move somewhere in this direction. So this is like 1 and 2 stuck together. They're moving together on some direction. So once they've collided, they're going to keep moving, but it's going to be at some angle. What is the velocity of the cars immediately after the collision? So we're looking for V12, the velocity of both of them stuck together, final. Okay, so because this is not a one-dimensional question, it's in 2 dimensions, things are moving in the x and in the y direction, we're going to have to do basically this question twice, once with x components, once with y components. So let's write out the x components of all of these vectors. So v2 and v1. So I have v1 initial x. So that V1 initial, it's moving upwards or in the north direction. What is the x component of it? It's only moving in the vertical direction. It's not moving in the x direction at all. So there is no x component. It would just be 0. What about V1 initial y? What is the y component of that vector? Okay, so we're assuming that up or north and east are both the positive directions. Put a little plus sign here. Okay, so V1 initial in the y direction, V1 is going only in the y direction, it's going in the positive y direction. So V1 initial y is 20 meters per second. What about V2 initial? X. So V2 initial is moving in the east direction, so it's already going in the positive x direction. So it just equals 22 meters per second. What about V2 initial y? Well, V2 initial is moving in the x direction. It doesn't have a y component at all. So that one would be 0 again. Okay, so now we know what the initial velocities are. What about the masses? We have m1 and m2. So the mass of object 1 was the 1,000 kilogram car, so it's 1,000 kilograms. And object 2, its mass was 1,200 kilograms. Now it doesn't matter whether we're talking about the x direction or the y direction. Mass is not a vector, it's a scalar, so it's the same mass in either direction. Okay, so we're going to go ahead and use the same formula that we did in question 3, which was total momentum initially before the collision is equal to total momentum final after the collision. So initially before the collision, we have two different objects, m1 v1 initial plus m2 v2 initial equals, after the collision, we really only have one object because the two objects stuck together. They lock together. So that means that they're just like one bigger object. So the mass of that bigger object is m1 plus m2. And the velocity, we're calling it v12 final after the collision. But now we need to do this once for the x direction and once for the y direction. So we're going to do the same thing twice. We're going to look at the x, all the x components that we've written down, so all the velocities in the x direction and in the y direction. So let's start off with the x direction. So I'm going to put a little x next to these, and I'm going to put little x's next to all of these. Okay, so we're doing everything only in the x direction, and I'll label it here just so it's clear for you. X direction. So m1, mass is a scalar, so the mass in the x and the y direction is both the same, 1,000 kilograms. v1 initial in the x was 0 meters per second, plus m2 was 1,200 kilograms. v2 initial in the x is 22 meters per second, equals m1 plus m2, so 1,000 kilograms plus 1,200 kilograms times v12 final in the x. Okay, there's a lot of subscripts. Notice I didn't rearrange to solve for v12 final in the x. I should have done that, but I didn't, and it doesn't really matter. In the end, I'll get the same answer. It just means I have to type things more than once on my calculator. Okay, so I'm going to type everything that's on the left side of the equal sign. I have 1,000 times 0 plus 1,200 times 22, and I get 26,400. And when I multiply the units, I get kilogram meters per second. So I'll put those in. You don't need to put these in though if you don't want to. Is equal to, on the right side, I have 1,000 kilograms plus 1,200 kilograms, which is 2,200 kilograms. v12 final x. I'm solving for that v12 final x, so I'm going to divide both sides by 2,200 kilograms. And you'll see the kilograms cancel out, and the 2,200 kilograms cancel out. And I have v12 final in the x direction is 26,400 divided by 2,200, and that's exactly 12. And the units are meters per second. Okay, so it's a positive value, implying that it's going to the right. So I'll just put that, actually it's going east. So I'll just put that in here so that I remember. It's positive, we're doing the x direction. X direction is either east or west, but since it's positive, it's east. So we're going to do the same thing over again, but this time with the y direction. So the formula is exactly the same. we have P total initial x equals P total final x. Sorry, this time we're doing y. So these are y's. And then we have m1 v1 initial y plus m2 v2 initial y is equal to, now they're stuck together, so it's m1 plus m2 because we only have one object now, which is made up of two vehicles stuck together, v12 final y. And we're solving for that v12 final y. So let's go ahead and rearrange for it now. We're just going to divide both sides by the m1 plus m2 over here, so that they cancel out. Do the same thing on the other side. And now I'll solve for my v12 final in the y direction, which equals m1 v1 initial y plus m2 v2 initial y over m1 plus m2. Now we're going to just substitute all the values that we know. M1 is 1,000 kilograms. V1 initial y is 20 meters per second, plus M2, which is 1,200 kilograms. V2 initial y is 0 meters per second, over M1 plus M2. M1 was 1,000 kilograms, plus M2, which was 1,200 kilograms. And now we can just type all of this up on our calculator. So we have 1,000 times 20 plus 1,200 times 0 divided by 1,000 plus 1,200, which is 9.09. Meters per second. It was a positive value. We're talking about the y direction. In this question, positive y direction means north. So I'm just going to put north here in brackets. Okay, so now we know the x and the y components of the final velocity of these two objects that are stuck together. But the question doesn't want just the final x and y components. It wants the velocity. What is the velocity? Meaning it wants the magnitude and the direction. So this is our final step now, is we're going to put those two velocity components together and recompose them to get the hypotenuse, which is the magnitude, and also find the angle so that we can give a direction as well. Okay, so we want to recompose the vectors. We have one vector, the final velocity 1, 2 of x in the x direction, which is pointing 12 meters per second in the east direction. So that looks like this, 12 meters per second. And we have another one that's going 9.09. I'm just going to put this on the bottom to give us space. 9.0909 meters per second north. So that's going like this. So the resultant would be the hypotenuse of that. So if I were to draw it, it would start from the beginning of the first vector and end at the end of the last vector. So this right here is v12 final. Okay, this is the x component, this one's the y component, and the hypotenuse is the resultant. Now we have to find the magnitude, and we have to give the direction as well, because the question's asking for velocity. So that means we need to give both magnitude and direction. So how do we find the magnitude? We have a right angled triangle, because one vector is going east, the other one's going north, so they're perpendicular to each other. And we know two sides of the triangle, we're looking for the third side, so we're going to use Pythagorean theorem. So The hypotenuse has to be C, and the other two sides can be A and B. It doesn't matter which is which. So let's say this one's A and this one's B. So Pythagorean theorem is just A squared plus B squared equals C squared. My A is 12 plus B, which is 9.0909 squared, equals C. My C is called V12 final squared. So now I just need to get rid of that square root. So I'm going to square root both sides. 12 squared plus 9.0909 squared equals V12 final. I'll just flip the 2 and type this on my calculator. Square root of 12 squared plus 9.0909 squared is equal to 15.05. This is a velocity, so the units are meters per second. Now there should be a plus or minus in front here, but we're going to ignore the minus. We're going to give a direction based on which way that vector is pointing. So the magnitude is 15.05 meters per second. Now we need to find the direction. To find the direction, you always put a little angle symbol, which we usually use theta as our symbol for the angle. And we use that to show which direction the final velocity vector is going. So that angle needs to be from the beginning of the final velocity vector. So you wouldn't be using this angle up here at all. Okay? So how do we find that angle theta that we drew in there? Well, we know the opposite side of the triangle, and we know the adjacent side of the triangle. So we should be using SOHCAHTOA. And since we know O and A, we're going to use TOA. Tan of our angle is equal to opposite over adjacent. We're looking for the angle. The opposite is 9.0909, and the adjacent is 12. Now we're trying to solve for the theta, so we need to bring the tan to the other side. And to do that, we do tan inverse. 9.0909 over 12. And now I can just type this onto my calculator. Tan inverse of 9.0909 divided by 12. And I get 37.1 degrees. All right, so we're nearing the end. At the final answer now we're ready to enter would be V12 final with a vector over it, because we're going to give both the magnitude and the direction. The magnitude is 15.05 meters per second, and in brackets we can write the direction. So how do we say the direction that this resultant vector is going? This vector right here. How would we state that direction? It's going east, right? This is the east direction. And from there, we're going 37.1 degrees towards the north direction. Okay, you could have also written 31 degrees north of east if you prefer that way. And that's it. That's the final answer. Okay, so that was quite a long question. I know that these questions take a long time to do, but the key here is that you want to divide the x direction and the y direction from each other. Do them separately. Once you have the final velocities in both the x and the y direction, you need to recompose the vector. So you're going to put the two vectors together, add them together to find the resultant, which is the hypotenuse. Remember, when the question asks for velocity, velocity is a vector, so you can't just give the magnitude or the speed, 15.05 meters per second. You also have to include the direction itself. Okay, so I hope that helps. Thanks so much for watching, and I'll see you next time. Thank you.